Hello, I'm Reyer Gerlagh, Professor of Environmental Economics at Tilburg University. I frequently use computer models for my research. After COVID-19 emerged as a pandemic, I read many articles and I thought about the models describing the spread of the virus. I like to share my summary of those models. I'm not an epidemiologist, nor a virologist. My description has not been tested by fellow scientists and is mainly a summary of my own understanding. I hope my explanations are of help if you want to understand what is going on. This is the fourth video in a series. In this presentation, I want to look at a few superspreaders. The question is what the influence is of these superspreaders on COVID-19. We look at 6 groups. First, we look at the social people who have many contact moments. Then we look at the role of large meetings. Then we look at professions where people have many contact moments. The fourth group has many mutual contacts. And the fifth group are households. Finally, we look at those who superspread not due to different behavior, but who are more infectious. Some people have more contacts than other people. These people have a higher R. They contribute much more to the spread of COVID-19. Suppose someone has twice as many contacts as the average. This person is then twice as likely to have an infection. And, if infected, passes the disease on to 2 people. This person is a link in the transmission channel of COVID-19 4 times as often as someone with an R of 1. The contribution of a person with RS2 to the spread of COVID-19 is therefore 4 times as great. The lesson we learn is that everyone should participate, keeping distance and reducing contacts. If some people have more contacts, they contribute much more to the virus spread. In a football match with many supporters densely packed, there are many opportunities for infections. This also applies to festivals, religious services, and fairs. Can we hold large gatherings? Not really. If you are more likely to be infected at a meeting, you should go into isolation afterwards. Small meetings are less likely to cause many infections. We do not know yet what types of gatherings we can allow. In some professions, you have intensive contact, such as physiotherapy, or you meet many people, for example in a restaurant. For people with such a profession, the R is much larger than 1. These people are more likely to be infected and they pass on the disease to more people. Their contribution to the spread is therefore much greater than that of average people. This means that if a job is not essential, we will have to do with less of that for the time being. As long as COVID-19 has to be suppressed, restaurants cannot operate at full capacity. We must protect the interventions of social distancing. We can try other solutions for essential professions. For example, by spreading the work over more people, there is less transmission. If some groups of people have more contacts or keep less distance within the group, it is possible that people in that group have an R above 1. We can think of a sports group, a church, mosque, or group of friends. This means that within that group, COVID-19 tends to increase exponentially. Ultimately, the members also infect people outside the group. The lesson from this is that the group with the highest R determines the speed of the outbreak in a country. It is important that there are no groups that are less compliant with the rules. A household is a special group. In large households, people have more contact moments than in one-person households. These contacts count for your individual R. The fact that your housemate is the same person every day is less important for the risk of infection than the number of contact moments with those persons. A large household has a much higher chance of becoming a link in the chain of an infection. That explains why it is important to also follow social distancing rules in your household if you live with many people. such as in a student home. Some people are more contagious than others. Once in a while, a super contagious person is identified who infected not one, not two, but above 10 others. Contagiousness is a biological trait for which we still have very limited predictive power. We cannot identify members of society that are biologically more likely than others to spread the virus. Though there is some evidence that kids are less contagious and elderly more. For those people where we can assess a low propensity to spread the virus, we can relax social distancing interventions. For others, where we anticipate a high propensity to spread, we tighten the rules. For those cases that we cannot identify, we must rely on general rules, such as prohibiting large gatherings, as these offer too many opportunities for unobserved superspreaders. The summary of this video is that individuals and groups with a big R are a big problem in suppressing COVID. The contribution to the spread of the virus tends to be quadratic in the number of contacts. We should thus also try to keep the R as low as possible within groups. This was the fourth presentation of a series. Thank you very much for watching. I hope it helps you understand COVID-19 better. As a scientist, I add a disclaimer. I am professor of environmental economics. I'm not an epidemiologist. I have read a lot of medical literature about COVID-19, but if you find I made mistakes, please let me know. Thank you.